Hello, this is Dr. K. In this video, we're going to look at how to use the Retrofit library with an Android application to get a list of GitHub repositories. We will provide the name of a GitHub user in the application. We're going to just hard code it for now. And we will get back a list of their repositories. Then we will display the names of those repositories on the screen using a recycler view. This application is based on the Getting Started Retrofit tutorial, which you can find on YouTube. Some of the differences between this application and the application in the tutorial are: 1. This app will use Kotlin instead of Java. 2. This app will use view bindings instead of find view by ID. And finally, 3. This app will use a recycler view instead of a list view to display the list of repository names. To see how the Retrofit library fits into the Android architecture, take a look at this diagram of the Android architecture using a repository pattern. The repository component of the Android architecture controls access to data regardless of where it comes from. For example, it may come from an SQLite database, in which case the application probably makes use of the Room library. The data may come directly from the model, in which case the data lives in your phone's memory while the application is running. Or the data may come from a web service. This last scenario is what we're going to explore in this application. The data will be on the web, and it will be accessible via a REST API. To facilitate the retrieval of this data, we're going to use the Retrofit library. The Retrofit library helps you get data from a REST API and turn it into Java or Kotlin objects that you can work with in your application. The architecture of our Retrofit application will be simpler than the Android architecture we just looked at. It will not have a view model, and the actual model will consist of only one data class with a single property. The class is named GitHub Repo, and it represents a GitHub repository. The Retrofit library will help us access the data from GitHub using its REST API. The data will come back in the form of a JSON file, and a related library, JSON, will convert the JSON repository objects into Kotlin GitHub repo objects. A REST API is an API, essentially an interface, that conforms to a set of constraints. If the API conforms to all of these constraints listed here, it's considered RESTful. The two most important constraints you should remember are: 1, the API should support a client-server architecture, and 2, client-server communication should be stateless. The web uses a client-server architecture. The client sends a request to the server, and the server sends a response back to the client. Most REST APIs live on the web, which means clients and servers communicate via HTTP. Strictly speaking, you can satisfy REST constraints without using HTTP, but practically speaking, REST APIs are almost always found on the web. It's also important for the REST API to support stateless communication. That means that no client information is stored on the server. The server sees every request from a client as self-contained and independent from other requests. This means that the server cannot tell whether or not a request was made by a client that had already made a previous request. Methods used in a REST API correspond loosely to the CRUD methods used in a database. The most commonly used method is the GET method, which is used to access data from the server. However, you should know that methods do exist that allow clients to modify data on a server. Depending on how the API is implemented, clients may or may not be able to use such methods. To get started with our Retrofit application, we have to add the Retrofit libraries to our Gradle file. Since we're going to use view bindings, you also want to make sure that view binding equals true is in your build.gradle file. Finally, we're going to access information over the internet, so setting that permission in your Android manifest is also a good idea. The model we use is going to be super simple. We just have a data class called GitHub repo that contains one property, a string. The string will represent the name of the repository. The GitHub client class that you see here is actually an interface that will be implemented by the Retrofit library. The implementation is guided by the annotations we provide in the interface. Here, we want it to create a function, repos for user, that takes a GitHub username and returns a list of the repositories owned by that user. To get the annotations for this function correct, we have to go to the web-based documentation for GitHub's REST API and see how to get what we want. A good place to search for what we want is to look at GitHub's app-enabled endpoints. These are going to be the URLs that we can potentially use in our application. If you look under the heading Repos, you will see that the last URL takes a username and has repos as the last word in its path. APIs are typically named so that the last word indicates what you are accessing or updating. Notice that the return type of this function is not a list of repos, but rather a call object that holds a list of repos. The call object is what ultimately sends the request to the server. It allows the network request to run on a background thread. Now recall that Android does not allow network access to occur on the main UI thread. After we create the binding and assign both a linear layout manager and the repo adapter to the recycler view, we build the retrofit object. To do this, we call retrofit.builder, pass in the base URL, and add the JSON converter factory. JSON is a companion library to Retrofit that converts JSON to Java and/or Kotlin. We need this because the list of repos will be returned in JSON format. We told the repos for user function that we are expecting a list of GitHub repo objects. So JSON will do its best to convert the JSON into a Kotlin list of GitHub repo objects. We've glossed over a few things here. The holder and the adapter for our recycler view will be covered in the next slide. And in the slide after that, we'll talk about the invocation of the enqueue function by the call object. The holder and adapter are fairly simple. The holder sets the text of a list item in the recycler view to the appropriate text from the model, and the adapter holds a list of GitHub repo objects. Recall that the call object is used to send the request to the server. It turns out that there are two main ways of doing this. In our case, the call object invokes the enqueue function. The enqueue function ensures that the request will be asynchronous, so that the UI can keep running while it's waiting for the response from the server. Another way the call object can send a request is through the execute function. If execute is used, the request is synchronous. So the UI has to wait for the response before it can do anything. The enqueue function takes a callback object that executes when the response from the server comes back. The response from the server can be success or failure. A failure can occur for any number of reasons. It will occur if there was a problem creating the request. It will also occur if there was an error talking to the server. And it will occur if there was a problem processing the response. For example, if JSON could not find a way to parse the JSON response from the server into a list of GitHub repo objects, then the call would fail. Notice that if the call fails here, the UI simply prints out a toast on screen, indicating that there was an error. If the call is successful, the response is saved in a response object that holds a list of GitHub repo object as the body of the response. The list is then saved to a repos variable. Notice the Elvis operator here. If the body of the response is null, the repos variable will be an empty list, so it won't crash the program. The list of repos is then passed into the adapter of the recycler view. This is the Java API for the enqueue function. You can see that it takes a callback object. It also lists the various ways that a call can end in failure. Here's the API for the callback interface. You can see that it contains the functions onFailure and onResponse. Notice that for Android applications, callbacks are executed on the application's main thread. In other words, the UI thread. This is an example of JSON data for a GitHub repo. Notice that there's a lot of data here, but only the name property is used in our application. When we run the application, you should get something that looks like this. This result is for the GitHub username Square. If you hardcode a different name, you should get a different list of repositories. And that's all for this video on a sample application using Retrofit. I hope you learned something, and I'll see you in the next video.